In lesson 5.7, we're going to talk about how to prove something to be true. And we're going to use our flowchart proofs in order to do this. Sometimes thinking backwards can be a useful strategy when we're trying to solve a proof. Let's look at the example above. This figure is called a dart, which means basically a concave kite. And in this concave kite, we're given some information. We're given that it is a dart called ADBC. I don't know why they called it ADBC. I guess I would call it DART. So let me just cross that off really quick. So this should be DART. And we know that side TD and side AD are congruent. So I'm going to write that down. So TD and AD are congruent. Let me mark that up. Those two are congruent. I also know that sides TR and AR are congruent. Because that's also given information. What we want to do in the end is we want to prove that DR bisects angle TDA. So when I'm saying that I want to prove that, that's going to be my last statement that I make. So down below, we know that we can show that DR is a bisector if we could show that the two angles are equal. So this statement here, if you look at it, is saying that if I look back up in the picture and I knew that the angle, let me erase that and use a different color. If I know that the angle from TDR is the same as ADR, then I know indeed that I will have proven that this DR is bisecting the big angle TDA. So that's going to be my final statement. And what you see here for your final statement, right here, in the orange, is the definition of what an angle bisector does. So what does that mean? That means, looking backwards, in order to make that true, we need to have corresponding parts of congruent triangles be congruent. What does that mean? That means if I look at the two different triangles, the one that's here on the left highlighted in yellow, and the one on the right highlighted in green, if I could show that those two triangles are congruent, I would have corresponding parts of congruent triangles being congruent. So that's what usually comes right before a final statement, past corresponding parts. And you can see that down below here if you look at where my arrow is to this information. So that would come right before my final statement of the DR is the bisector of TDA. So working backwards, in order to have corresponding parts of congruent triangles, I need to have two triangles being congruent. So I look at that picture and I want to show that the yellow triangle and the green triangle are congruent to each other. How do we do that? Well, as I look at these two triangles, again, the green triangle on the right and that yellow triangle on the left, I already knew from my information that these two sides were congruent and these two sides were congruent. And so if I could show somehow that the middle side was the same as itself, I would know that I would have two congruent triangles by side, side, side. I could say that the two triangles were congruent, side, 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 knowing that the triangle in the yellow, TDR, or RTD as they write it down here, was one of those triangles, and RAD, or I call it DAR, was the other one. Again, our final statement was going to be that we had an angle bisector, and previous to that, I had to show that two angles, were congruent to have an angle bisector. So as I move forward, in order to have that, I need to talk about the three pieces of those triangles. So trying to put it all together here, what I see is that in this very beginning, if I start from the very beginning, just kind of seeing how it all pieces out, I knew that in the beginning I had the TD and the AD and the TR and the AR being congruent. That was when I marked up the DT and the AD, the TR and the AR being congruent, and that was in the red. Remembering that we said that this was DART, D-A-R-T. So you see that down below in the red highlight here. I see that my TD and AD are congruent. That was given information. I see that my TR and my AR was given information. And what I'm going to do is I'm going to talk about the middle segment here, DR. And I know that DR is congruent to itself. So I say that in the third and final statement, that DR is congruent to itself because it's the same segment. And I notice that when I make those three pieces, I see that I have one side, two sides, three sides from two different triangles being congruent. Again, that was talking about my triangle on the left, which we call triangle RTD, and my triangle on the right, which we call triangle RAD. And so since we have three congruent sides, we take these arrows and we point them to our next conclusion, which is in fact those two triangles are congruent to each other, and they're congruent to each other by the side, side, side theorem. So this pink highlighted circle is the result of knowing that there are three separate pieces from each triangle that match up, and they're all sides. Always after we prove that two triangles are congruent, we want to make a statement about what logically follows next. And what logically follows next is the fact that we have two corresponding parts that are also congruent. In this particular case, those corresponding parts are the ones that we're referring to before, which were the two angles, angle TDR in the yellow triangle and angle ADR in the green triangle. And so I say that those two triangles, those two angles are congruent to each other, and that's because they were the corresponding parts of two congruent triangles, and so they must be congruent. Once I've done that, I know in the end that the segment DR must be the bisector of the big angle TDA, this big angle right here, TDA, because that's the definition of what an angle bisector is. It chops an angle into two congruent pieces. And so thinking backwards sometimes is a strategy that you need. For some of us, we won't necessarily use that, but in the end, we've proved that DR is bisecting TDA. First set of statements are three pieces from two triangles, showing that they match up. The second statement is the two triangles being congruent. The third statement is corresponding parts in two congruent triangles are congruent. That always follows a congruent set of triangles. And finally is the proof statement, because we know that those two angles in brown are matched up. We know that we have an angle bisector.